So now we have another equation to graph. F of x equals ln of x over x. So let's see. The domain of this, by the way, let's deal with that. The domain, because the domain of the logarithmic function, natural log function, is 0 to infinity. And so the domain equals, and it can include 0. And of course, we couldn't let x be 0 anyhow because we can't divide by 0. So it's going to be 0 to infinity. So we've got that little job done. And now let's take a derivative. So f prime of x, and you have to use the quotient rule. And when you do that, and you've got it all done, I get that thing equals 1 minus ln of x over x squared. And setting that equal f prime of x equal to 0 to find the critical value, we get equals 0 at x equals e. So let's make a little graph of that, number line graph, and we'll put e here. And we can't be 0. And notice, if we put a value, say, less than e in for x, we'll get a positive slope. If we put a value in greater than e in for x that's greater than e, this term will dominate and will be negative. Now, that means, by the way, we have a positive slope going up to some point, up to the point, and I'll tell you what the point is. It's going to be e and f of e, but f of e is 1 over e, because if you replace x with e, you get ln of e is 1 and an e in the denominator. So now let's find the second derivative. And the second derivative is when you use the when you use the quotient rule, I get 2x, or 2, I beg your pardon, ln of x minus 3 over x cubed. When you simplify, you get 2 ln of x minus 3 over x cubed using the quotient rule. And so f double prime of x equals 0 at x equals e to the 3 halves. And this is where the inflection point's going to be. And what's the ordered pair associated with that? Well, it's going to be e to the 3 halves. And if you evaluate f of x for e to the 3 halves, you wind up with 3 over 2 e to the 3 halves. And we'll do a little graph of that. And here we are at 0, and we're open circle. E to the 3 halves, and we are concave down, picking a value. And what value did I choose? Yes, I looked at f double prime of let's see, if I look at f double prime of 1, we'll be less than 0. If I pick a value such as f double prime of something greater than e to the 3 halves, like, let's go e to the 4th, will be greater than 0. So on this interval to the right of e to the 3 halves, we're positive. Now I think we're ready to graph our function. So we know what the concavity is. It's concave down on this interval. And so let me magnify things, and we'll go over here to e. So here we are at e, and 1 over e. And here we are at e to the 3 halves, e to the 3 halves, and 3 over 2 e to the 3 halves. And our curve is its slope is positive till it gets here, and then it turns negative. And we've got an inflection point right here, so we change concavity, and our horizontal asymptote, our horizontal asymptote is y equals 0, because as the x gets larger and larger, it gets there at a faster rate than ln of x increases. So the horizontal asymptote is 0, and there is our graph, and we're done.